Oh, hi. It's me, your favorite Bio 2 teacher, John Kinsley. Welcome to the Learning Academy, the Distance University of Hamilton Township Academy of Learning College. I'm Professor Kinsley. I'm also the Dean of the Biology Department and the President of the College of Arts and Sciences. And I want to welcome you to today's learning experience. Let's talk about plants today. So if you stick around to the end, I have a little secret to tell you. Okay? So how's that sound? Let's go. Okay, so our notes have number 1 asking about the types of organs and tissues in plants. Nope, just organs, not tissues. Took that part out. So just organs. Anyways, we're only worried about vascular plants. Non-vascular plants are idiots, and they don't have any way of transporting stuff, and they're weak and they're timid. That's not true. I do love me a moss or two. Anyways, what are these organs that we find in vascular plants? A roots, a stems, and a leaves. All right, so that's what we're going to talk about in this section of the notes. We'll try to figure what these things do and how they work, how they function, and some of their basic structures. The next 3 chapters we'll talk about have to do with more detail on roots, more detail on stems, more detail on leaves. Roots! What do? Well, you already know the big boy, which is they absorb stuff. They absorb water and dissolve materials. We know this about roots. But what else do roots do? Well, we got 2 more things, because more things. Where are we, number 2 of our notes? Yeah. Hey, hold that plant down, boy. So they anchor the plant to the ground. And then the third function is one you guys never think of. If I were to stand here in class and ask you, hey everyone, what are the 3 functions of plant roots? You would get those first 2, no probs. But that third one, So anyways, here it is. Defense. So the plant has to protect itself against junk in the soil. The rest of the plant doesn't have any kind of interface with a hard object. It's just the air. Leaves and stem are in the air. No, not for roots. So anyways, protection, that's another key important part there. Okay, let's talk stems. Stems have another 3 kind of important functions. Again, we're on number 3 of our notes. I do keep glancing over at my notes. I have them there to look at. So 3. Stems, so hold the plant up, right? They're strong, they're supportive, right? You also got to transport materials through the stem. We're talking water, we're talking food. So thank you. And what's that third function stems have? Ooh, you may be wondering, is it like roots where we didn't think of that third one? It is like that. So we're talking about you got to defend the plant. So protection. So we're talking half thick bark. We're talking some chemicals in the stem that makes things not want to eat you. And we're talking thorns. Now that's a good visual. Okay, leaves. So what are leaves doing? We know this about leaves. They are photosynthesizing. That's all they do all day long. Making sugar for the rest of the plant. So that's the big one. And then the other thing about them is that they are good at doing photosynthesis because they have a large surface area. So big flat surface, real efficient at photosynthesis. All right. Now here comes the time of my PowerPoint where I say to you, who wants a Kinsley buck? You want one? You want one? You want one? You want one? Well, if you can name this plant on the bottom left of your screen, do you know what that is? I do. Who knows? I'll give you a second to think about it. That means just pause the video. Okay, we're back. That's a watermelon. Did anybody get it? No, no Kinsley bucks. Sorry. And this boy right here is a Canada leaf. That's actually a sugar maple that's in the middle of the Canada flag right here that my face is. Here we go. Whew. Let's try to see it closer. Okay. Okay, that takes us to number 5 of our notes. So we want to talk about the tissue systems that plants have, and there are 3. We got these guys called dermal, vascular, and ground. You're surely somewhat familiar anyways with vascular tissue. So that's, of course, well, we'll talk about that in a second, but we'll talk about that in some detail in a minute. So worry about that later. For now, we're on number 5. Get these down, and we'll talk about each of those in a second. All right, dermal tissue, the first of these 3 tissue layers in plants. So it's the outside layer. Like, it sounds familiar to you because you've heard of epidermis, haven't you? Like your skin. When have you gotten a shot before? You use a hypodermic needle. Hypodermic means, hypo means less than or under. Derm means skin. So there you go. It's a needle that goes under your skin. Okay. So the epidermal cells are the outside layer. So that will hit you up with number 6. Okay. The other thing we got to talk about is something we mentioned before when we were talking about how plants keep the water that they have in. That's to have a waxy layer called the cuticle. And that will hit number 7 for us in the notes. So the cuticle's job is this waxy layer to prevent water loss. It prevents evaporation. So that's what we got with the dermal tissue layer. A couple more notes about the dermal tissue layer. They have some different functions in our different organs. So the roots and stems and leaves, they all do something a little bit different. So in leaves, that's when we're talking about the epidermis and also the cuticle. In a stem, the dermal tissue layer, or in roots, sorry, the dermal tissue layer consists of these things called root hairs, which we'll discuss in some detail later, actually in the next chapter. So root hairs are there to absorb water. That will do part of number 8, and then the rest of it is these things called guard cells, which open and close these openings in a leaf called stomata. So they permit gas exchange. So summary, in roots, we're talking root hairs. In leaves, we're talking guard cells. I did it. Okay. Next. All right, so that takes care of dermal tissue. Vascular tissue. So we know that vascular tissue is about transport, right? So we'll be talking on the table that I have there on number 9 of your notes. We'll talk about the cell types that make up vascular tissue and exactly what they're doing. So just kind of an overview, we've got this stuff called xylem, we've got this stuff called phloem, which is a different word from phylum. Different words. Xylem and phloem. So these are our 2 vascular tissues that we find in plants. So xylem carries water, phloem carries food. That's easy to remember. Phloem, food. Don't forget it. Okay. Did you forget it? No. All right, to finish our table for number 9. So we have special cell types that I'll show you that make up our xylem, make up our phloem. So xylem is made up of 2 different cell types. They're called tracheids and vessel elements. I'll show you how those work in a moment, and in the subsequent questions talk about them. So on the other hand, we have phloem, which consists of 2 different cell types also. Those are called sieve tube elements and companion cells. More on those momentarily. Stay tuned. Okay, there we are. So xylems, we've got in the visual here, tracheids and vessel elements. So the question number 10 and 11 ask about these. So 10 says, well, how does water move from one tracheid to the next? Well, if you can look at the illustration, our tracheid points to these really kind of narrow tubes that are divided. You can see how they have these perforated little divisions. These cell walls have holes in them, so they're perforated. So water goes between tracheids from one tracheid to the next through those little perforated or kind of poked openings. There are little tiny openings in those walls between them. So there you go. I maybe should have gone to that bullet point quicker. All right, and then for 11, how does water move from vessel elements? Well, they, as you can see in the illustration, are continuous tubes. So there's no cell wall between each of those. It is just a long continuous straw. So water has to go between little perforated cell walls between our tracheids. Not so with our vessel elements. They are just long continuous tubes. Okay, so now we're hitting up the phloem, and let me maybe go back and think about the direction of water flow for a second, material flow. So xylem carries, what's xylem transport again? Water. Yep, xylem carries water. So what's the direction of the water? Well, the water is absorbed by the roots, so it must be upward towards the leaves. Well, phloem is carrying food. Well, what makes the food? Leaves. So leaves make the food, the sugar, and it's moving down. Here, just hold on. That looks so cool. Moves down through the phloem. So the two cell types here are sieve tube elements, which is, as number 12 asks, it's the actual cell type where stuff moves. You can see the cells are, again, perforated, so there are holes in between the cell types of our sieve tube elements, and those things are a lot like tracheids in that way. But again, the direction of fluid motion is downward in the phloem to the rest of the plant, and it is upward in the xylem, right? Because water is absorbed in the roots. Yes. So those are sieve tube elements. They do all the transport in the phloem. The other cell type is, well, we'll hit that in a second. You'll see. Okay, so the other cell type found in phloem are companion cells. So companions are friends. Companion cells, in the case of phloem, don't do any of the transporting themselves. All they do is they help, I guess, help how stuff moves in the sieve tube elements. Actually, we don't have a firm idea, a firm grasp on how that operates yet. So people would like to know. Well, later we'll talk in some detail in chapter 23, section 5 about exactly how water moves through the xylem. We know that. It's a little harder for us to explain how sugars and other materials move through the phloem. Anyways, what we do know is that companion cells, as you can see in the illustration, they're not hollow, they're solid. So nothing's moving through them. They are there to assist movement of stuff through the sieve tube elements. Okay? So they're good buddies. That's all they do. That's their only job is to help out. Comprende? Okay, so number 14. So what type of tissue is between vascular and dermal? Well, that leaves one, and it's ground tissue. And we won't talk about the three kinds of ground tissue, parenchyma, collenchyma, sclerenchyma. But you should know that it is important in a lot of the things that plants do. It takes different roles in different plant organs, so roots and stems and leaves. The ground tissue plays different roles. But you can think of it as kind of like the filler. It's if you got yourself a burrito, let's talk burritos. The tortilla is the dermal tissue. The vascular tissue is the tissue transporting the sour cream. I regret my analogy, but ground tissue is the rice. Rice just fills that boy up. You've seen when they make the burrito, it's like 90% rice. Anyways, I won't re-record this. I'll just keep this. This is fine. Okay, a couple other big picture important topics here to talk about in this section. So 15 says, what the heck is meristem? Well, there's this tissue in plants. It's not separate from dermal tissue, ground tissue, or vascular tissue, but it is called meristematic tissue or meristem. So this is at the ends, as you can see there, of roots and stems. It is tissue of growth. So if you're describing meristem, easiest thing to do is say tissue of growth. So this is how stems get longer, for example, how roots grow deeper into the soil. It's because of meristem. It's where there's lots of cell division happening constantly. So let's look at a little particular area of meristem in a second. So these new meristem cells that are made. Well, the meristem, if it's tissue of growth, the cells are not determined yet, which means they are described as undifferentiated. So as the cells become mature, as they age, they differentiate, they become specialized. So number 16 says, what's differentiation? It is as cells become specialized. So maybe it's going to become a root hair cell. Maybe this meristem cell is going to become a part of a flower later on. It depends on the situation. So a good analogy here, especially because we're talking plants, is in humans, the kind of cells that become any other type of cell we call stem cells. That's right. It's what is like that. It can become any other cell type. So all the tissue, all the cells here in the meristem, that is undifferentiated. It is unspecialized. Okay, so the special kind of meristem tissue at the end of roots and stems, it gets a special name, which is the apical meristem. Apical as in apex, like the point of this cool hand triangle I'm making for you is the apex. So that's what apical means. It means apex. You heard an apex predator, the top of a food chain? It's the top, it's the end, it's the point. So maybe it's the end of a stem growing outwards. Maybe it's the end of a root growing downwards. Here it is. Through the soil, but that's the apical meristem. And it's pronounced apical meristem. All right, so what are the organs of seed plants? Is that long enough for you to think or to have paused? I don't know. So root stems and leaves. Okay, so phloem cells that surround the sieve tube elements. So of our two cell types that make up phloem cells, we've got sieve tube elements and then the boys that help them out. That's right, companion cells. You've done it. What are the cell types that can turn into any other cell type, depending on their situation? Yup, meristem, meristematic tissue. Yes. So let's think about that meristem. When the cells there first show up, can you tell me about them? Are they specialized? Are they not? Are they dividing a lot? Are they not? What's the best combination of those two? That's right. D is in duck, unspecialized, and then they divide a lot. Areas of growth, so there's lots of cell division. Shh! It's time for secrets. Well, secret. Thank you for making it to the end of chapter 23, section 1. I thought I'd tell you a secret about myself, and here's one I thought about that I think only my brother knows. Anyways, when I was a kid, I lived on a cul-de-sac, and I was out one day, one nice shiny summer day, hitting a tennis ball with a baseball bat. Just doing what a kid does, keeping himself busy, not thinking, just doing. Anyways, I cranked myself a dinger. I hit that thing way over my house. And I was standing in my cul-de-sac, boom, having smoked that thing over my home, over the roof, and I celebrated. I celebrated by doing this wicked cool bat flip. Whoopah! And I was like, yeah! Bat hit me square on top of the head, knocked me clean out. I woke up just laying in the middle of our cul-de-sac all by myself. Nobody saw me, no neighbors, but I did throw a big heavy aluminum bat in the air high enough that when it did hit me in the head, it did knock me out. So that's a secret, and I'm not real proud of it, but humble brag, did hit a dinger over my home.